Oh, so this example is going to be one that has two asymptotes. So with all of these examples, with all of these graphing problems, we always want to start out with factoring if necessary. So if I factor the top of this one, I am going to get x plus 3, x minus 2. And if I factor the denominator, I'm going to get an x plus 1, x plus 5. So notice that nothing cancels out. So when nothing cancels out, that means that there is no point of discontinuity. Now, some homework might say OA, and OA is something that we didn't do this year, so you can just cancel that out. There's going to be a horizontal asymptote, not oblique asymptote, which is something we didn't talk about. So nothing cancels out, which means there's going to be two vertical asymptotes. So to figure out the vertical asymptote, we set the bottom equal to 0. So -1 and -5 are going to be the two. So x equals -1, x equals -5. Next, for the horizontal asymptote, my eyes would go back to the original problem because that's where I will look to see that it's the same degree on the top and bottom. So the horizontal asymptote is the ratio of the coefficients. So 1 over 1 is 1. Y equals 1 will be the horizontal asymptote. All right, x-intercept is the top equal to 0. So I will have two x-intercepts, which is allowed, at -3 and at 2. And then the y-intercept is the ratio. Again, my eyes are going to go back to that original because it's the ratio of the constant. So -6 over 5 is the y-intercept. Okay, so let's go ahead and plot everything that I know. I might need to find some more points because especially with these two asymptote problems, you probably will need to plug in up to 4 extra points. Let's see what happens when I graph the points that I know already. So I have my two vertical asymptotes, and then I also have the horizontal at 1. All right, so remember, in the middle section of the two vertical asymptotes, it's allowed to cross the horizontal asymptote, so it might do that. Let's plot the x-intercepts. So -3, 0 is right here, and also 2, 0. So the 2, 0 is really helpful. Let's plot the y-intercept. It's -6 over 5, which is like -1 and some change, which makes sense because we can see that this part of the graph, this is why the x-intercept was helpful, is going to be down in that corner. So here's the thing. I am going to need to plug in some points. I'm going to highlight them. I'm going to need to plug in something over here and over here. So again, I need to see, is this going to go up or is it going to go down? To figure out that, I'm going to plug in -2. What about the other side? Is it going to go up or is it going to go down? I'll plug in -4 to answer that. And then I also need to know, is the graph to the left of the left asymptote going to be up or is it going to be down? So I need to plug in any one of these points to figure that out. So let's start with f of -2. I would plug into the factored version. It's just going to go a little bit faster. So on top, we're going to get 1 times -4 over -2 plus 1 is -1 times 3. So that's 4 over 3. So 4/3 is at -2. So that's 1 1/3. So that's going to be here, which tells me this chunk of the graph is going to go up this way. Now let's plug in -4. Okay, on top, -4 plus 3 is -1. -4 minus 2 is -6 over -4 plus 1, -4 plus 5. Okay, so that's +6 over -3, which is -2. Nice, so -4 is at -2. So that tells me that this chunk of the graph is actually going to go down. Okay, and then we got one more. So let's go ahead and find f of, I'm going to pick -6 That's closest to the asymptote. Usually we get a little bit of nicer numbers. So f of negative 6. On top, negative 6 plus 3 is negative 3. Negative 6 minus 2. Negative 8. And then negative 6 plus 1. And negative 6 plus 5. Okay, we get a 24 over 5. So 5 goes into, what, 20 4 times. So this is like close to 5, 4 point something. But that is enough to tell me that it's up here, which means that this chunk of the graph is going this way. So there is a graph with two asymptotes. Definitely a lot of work, but worth it.